Like, imagine you're trying to cram every single person on Earth into one room.
Oh, wow.
Impossible.
Yeah, that's
It just wouldn't work.
No.
And that's kind of the idea behind this thing called the Pauli Exclusion Principle.
Okay.
But instead of people, we're talking about tiny particles like electrons.
Right.
The stuff that makes up, everything around us.
Uh-huh.
So today we're going deep on this wild concept.
Okay.
And our guide is this book, Physics Fundamentals Explored.
Cool.
So let's break it down and see why it's such a big deal.
The fascinating thing about the Pauli exclusion principle is that it's this really simple idea,
Yeah.
but it has these enormous consequences.
Right.
It basically says that no two electrons in an atom can be in the same quantum state.
So it's like electrons need their own personal space or something?
Yeah, exactly.
Okay, but what does that even mean in an atom?
Right. To understand that, we need to step back in time a little bit.
Okay.
Back to 1925. Scientists were puzzled because the model of the atom they had at the time couldn't explain why electrons didn't just spiral into the nucleus.
Oh.
Like if planets just crashed into the sun.
Right.
It just didn't make sense.
Yeah, that'd be chaos.
Total cosmic chaos.
So how did they figure this out?
Well, along came this physicist, Wolfgang Pauli,
Okay.
and he proposed this game-changing idea.
Yeah.
He said that electrons can't all just cram into the same energy state. They need their own unique address within the atom.
Okay.
And this address is defined by something called quantum numbers.
Quantum numbers?
Yeah.
It's kind of complicated.
They're not as scary as they sound.
Okay.
Think of it like an apartment building as an analogy for an atom.
All right, I'm with you.
The principal quantum number is like the floor number,
Okay.
indicating the electron's energy level.
So higher energy.
Exactly.
Yeah.
Then you've got the angular momentum quantum number,
Okay.
which describes the shape of the electron's orbital, like the shape of a room.
Okay.
And then the magnetic quantum number.
Ah.
That tells us the orbital's orientation in space.
So north, south, east, west.
Yeah, you got it.
So we've got the floor, the shape of the room, and which way it's facing.
Right.
What else?
Finally, there's the spin quantum number,
Oh,
which
wow.
is like the electron spinning on its axis,
Okay.
either clockwise or counterclockwise.
Gotcha.
So each electron has its own unique combination of these 4 quantum numbers.
So their own address in that atomic apartment building.
Exactly.
Yeah.
And the Pauli exclusion principle says that no 2 electrons in an atom can have the same set of these 4 numbers.
Right.
So no 2 electrons can be on the same floor in the same shaped room,
Okay.
facing the same direction and spinning the same way.
So no identical twins sharing a room and spinning in sync.
You got it.
Okay, that's a good analogy.
Yeah.
But why is this so important?
Right.
I mean, this is happening on such a tiny scale.
Uh-huh.
Does it really affect our everyday world?
It absolutely does.
Really?
It actually explains the very structure of the periodic table.
Oh, wow.
Why different elements have different properties.
Okay.
For example,
Yeah.
let's take the simplest elements, hydrogen and helium.
Okay.
Hydrogen has 1 electron occupying its ground floor studio apartment, so to speak.
Okay.
Helium has 2 electrons.
Right.
So one's spinning clockwise, the other's counterclockwise.
Right.
It's the only way they can both fit in there
Okay.
without breaking Pauli's rule.
So because of this principle, each element has its own unique arrangement of electrons.
Exactly.
Interesting.
And as you add more electrons, they have to start filling higher energy levels, different shaped orbitals facing different directions.
Okay.
The Pauli exclusion principle creates this order and structure within atoms.
So it's like the architect of the atom?
Yeah, you could say that.
Cool.
It dictates how they bond and react with each other.
Right.
And ultimately, it shapes the diversity of the world around us.
That's mind-blowing.
It is pretty amazing.
I'm starting to see why this seemingly simple principle is such a big deal.
And it goes even further than that.
Oh.
The Pauli exclusion principle is crucial for the stability of matter itself.
Wait, really?
Without, everything would just collapse.
Well, okay, hold on. We got to unpack that. So you're saying without this rule, atoms just couldn't exist?
Yeah, pretty much.
Like how we know them?
It's not just about atoms collapsing, though.
Okay.
Think about it.
Yeah.
If this principle didn't exist,
Uh-huh.
all electrons would just try to crowd into that lowest energy state.
Yeah.
And there'd be no chemical bonds,
Right.
no variety of elements,
Okay.
no complex molecules.
So we're talking the basic building blocks of matter would be totally different.
Exactly.
Right.
No carbon, no oxygen.
No life as we know it.
Exactly.
Wow, that's heavy.
The Pauli Exclusion Principle is what creates the framework for complexity.
Okay.
It's that push and pull,
Yeah.
that need for electrons to find their own unique spot in an atom. That's what drives the formation of everything,
Wow.
from simple water molecules to DNA.
Okay, so I'm starting to see just how massive this is.
Yeah.
But let's go back to those white dwarf stars for a second.
Okay.
How does the Pauli Exclusion Principle work in those crazy environments?
So picture a white dwarf star.
All right.
This thing is so incredibly dense that, like, a teaspoonful of its matter would weigh tons here on Earth.
Right.
And gravity's constantly trying to crush it down even further.
So everything's getting squeezed together with, like, insane force.
Exactly.
Yes.
But here's the thing.
Yeah.
Electrons are fermions, right?
Right.
So they refuse to occupy the same quantum state.
Okay.
And this resistance to being squeezed together,
Yeah.
it actually generates an outward pressure, which is called electron degeneracy pressure.
Okay.
And that pressure pushes back against gravity.
So it's like a cosmic standoff.
Yeah, basically.
With gravity and the Pauli Exclusion Principle.
Yep.
And that's what's stopping the star from collapsing into a black hole.
Exactly.
That's insane.
It's a testament to just how powerful this seemingly simple rule really is.
It makes you wonder if this principle is at work in other extreme cosmic objects, too.
It definitely is.
Okay.
Well, really, like neutron stars,
Okay.
which are even denser than white dwarfs.
Wow.
They rely on a similar principle,
Uh-huh.
but with neutrons instead of electrons.
Oh.
And without it, they would also collapse further.
So this principle is, like, essential for these crazy objects that push the boundaries of physics.
For sure.
That's awesome.
So we talked about fermions and bosons earlier.
Right, right.
Do you want to dive a little deeper into what makes them different?
Yeah, definitely.
Okay, so the Pauli exclusion principle applies to particles that we call fermions.
Right.
These are like electrons, protons, neutrons. They have a spin that's a half integer value,
Okay,
like 12 or 32.
gotcha.
And they're kind of like the rule followers,
Right.
Each one demands its own unique quantum space.
So fermions are like the introverts of the particle world.
Yeah, exactly.
They need their alone time.
Right.
What about the extroverts then?
Those are the bosons.
Okay.
They have integer spin values.
Like 1, 2, 3.
Yeah, things like that.
Okay.
And they don't mind sharing the same quantum state.
Uh-huh.
In fact, under the right conditions,
Yeah.
they can all pile into the lowest energy state,
Oh, wow.
creating this thing called a Bose-Einstein condensate.
A Bose-Einstein condensate?
Yeah.
What is that?
It's pretty wild.
Okay.
It's where a bunch of bosons basically act like one giant superatom.
Really?
Yeah, they lose their individual identities and act collectively.
So it's like a quantum flash mob or something.
Exactly.
It's really cool.
It's a very strange and fascinating phenomenon.
So we've got these two groups of particles with, like, totally different social structures.
Right.
And it's all thanks to this one principle.
It is amazing.
It really makes you appreciate the diversity and complexity of the quantum world. And it highlights how the Pauli Exclusion Principle shapes not just atoms,
Yeah.
but the behavior of matter on a much larger scale,
Right.
for instance.
Mhm.
It plays a crucial role in the development of all these technologies that have revolutionized our lives.
Exactly.
You mentioned that earlier.
Yeah.
Can you give some specific examples
Of course.
of how the Pauli Exclusion Principle is impacting technology?
Sure. So let's start with semiconductors.
Okay.
These materials are like the foundation of modern electronics,
Right.
powering everything from our smartphones to computers.
Uh-huh.
And the way electrons flow through a semiconductor,
Yeah.
creating those electrical currents,
Right.
is governed by the Pauli Exclusion Principle.
So every time I check my email or scroll through social media,
Pretty much.
I'm unknowingly relying on quantum mechanics.
Exactly.
That's kind of cool.
It is pretty neat.
This principle is ensuring that the electrons are behaving correctly.
Right.
So my phone actually works.
Yeah.
That's amazing.
The principle makes sure that those electrons occupy specific energy levels within the semiconductor.
Okay.
So you get that controlled conductivity.
Right.
Without the Pauli exclusion principle, our electronics just wouldn't function.
That's wild.
It is pretty fundamental.
What about other technologies, though?
Sure.
Does it play a role in lasers, too?
Absolutely.
Okay.
Lasers actually exploit this principle.
Yeah.
to create those really cool properties of laser light.
Okay.
So you have electrons in a laser,
Yeah.
and they get excited to higher energy levels.
Yeah.
And when they fall back down to those lower energy levels,
Right.
they emit photons.
Okay.
But the Pauli exclusion principle ensures that all those emitted photons
Uh-huh.
are identical in wavelength and direction.
Oh, wow.
And that's what gives you that focused, coherent beam.
So from the tiniest parts of our phones and computers
Yeah.
to the precision of lasers,
Uh-huh.
this principle is everywhere shaping our technology.
It really is pervasive.
Are there any other, groundbreaking technologies
Sure.
that are being influenced by the Pauli exclusion principle?
Yeah. One of the most exciting frontiers is quantum computing.
Okay, I've heard about that.
It's still in its early stages.
Right.
But it has the potential to revolutionize a lot of different fields.
Like what kind of fields?
Things like medicine,
Wow.
materials, science, artificial intelligence.
So quantum computers,
Yeah.
how does the Pauli exclusion principle play into that?
So quantum computers basically harness the principles of quantum mechanics,
Okay.
including the Pauli exclusion principle, to perform calculations in a totally different way.
Different from our regular computers.
Exactly.
Okay.
They use these things called qubits.
Qubits.
Yeah.
Okay.
And those qubits can exist in a superposition of states.
Superposition.
Yeah.
My brain's starting to hurt a little bit.
It's a tricky concept.
Yeah.
Can you break that down for me?
Sure. Think of a coin that's spinning.
Okay.
Before it lands, it's both heads and tails at the same time.
Right.
That's kind of like superposition. Okay, I kind of get it.
And the Pauli exclusion principle played a big role in how these qubits interact and how they do their computations.
So it's helping us unlock the power of quantum computing.
Exactly.
That's incredible.
It is pretty amazing technology.
It seems like this principle has way more implications than I ever imagined.
It really does go beyond just the digital world, too.
Oh, really?
For example, it's crucial for understanding superconductivity.
Superconductivity.
Yeah, you mentioned it before.
Can you remind me what that is again?
Sure.
And how does the Pauli exclusion principle fit into all of that?
So superconductivity is basically the ability of certain materials to conduct electricity
Okay.
with zero resistance.
So no energy loss.
Exactly.
Yeah.
Imagine power grids that can transmit energy with no loss at all,
Right.
or levitating trains that just glide effortlessly.
That sounds like science fiction.
It does, but it's a real phenomenon.
That's so cool.
And it has the potential to revolutionize so many things.
So how does the Pauli exclusion principle make this possible?
It gets a little complicated,
Right.
but basically in these superconducting materials,
Yeah.
electrons pair up in a special way
Okay.
that allows them to move through the material without any resistance.
Wow.
And the Pauli exclusion principle governs how these electron pairs form and behave.
So it's the reason why superconductivity can even happen.
You got it.
That's mind-blowing.
It is fascinating how this seemingly simple rule about electrons is opening up all these doors to a whole new era of technology.
For sure.
It's like exploring a brand new world.
Totally.
And the Pauli exclusion principle is our guide.
That's a great analogy.
You never know where a basic principle might lead.
This has been an incredible journey.
I agree.
We've gone from the history to the science.
Yeah.
And even the mysteries surrounding this principle.
It's a rich topic.
It is.
And there's still so much more to explore.
Our source material mentioned some unanswered questions
Oh, yeah, for sure.
about the Pauli exclusion principle.
There are definitely still some mysteries.
Like what I'm intrigued?
Well, for one thing, we don't fully understand why fermions obey this rule.
Okay.
Like, what's the deeper reason?
Yeah.
What's so special about their nature
Right.
that makes them stick to this principle so strictly? And then there's the question of where those quantum numbers come from.
All right. Those electron addresses.
Yeah, those are still a puzzle for physicists.
So even with everything we've learned, we're still missing some pieces.
Exactly.
That's kind of exciting, though,
It is.
that there's still so much more to discover.
It keeps things interesting.
It really does.
That's what makes this field so captivating.
Okay, so before we wrap up,
Yeah.
what are your final thoughts on the Pauli exclusion principle? And, what's its significance?
Well, I think the most important takeaway is that even a simple idea can be incredibly powerful.
Okay.
At its core, the Pauli exclusion principle is a straightforward statement about how particles behave.
Yeah. But from that simplicity comes this incredible range of consequences that shapes everything
Yeah.
from the structure of matter to the behavior of stars.
Wow.
And it even affects the possibilities of future technologies.
That's amazing.
It's a testament to the elegance and profundity of the laws that govern our universe.
To all our listeners out there,
Yeah.
I hope this deep dive has made you curious about the world around us.
For sure.
Never stop exploring and never stop questioning.
Right.
Who knows, you might be the one to unlock the next big scientific mystery.
It could happen.
That's awesome. Thanks for joining me on this deep dive.
It was my pleasure.
Yeah, it really does feel like we've uncovered this, hidden rule book that's shaping everything around us.
Yeah.
From the atoms in our bodies to the stars in the sky.
It's pretty amazing.
It's mind-blowing to think
I know.
that something so simple can have such huge consequences.
It is remarkable, isn't it?
The Pauli Exclusion Principle really shows us that even in the vastness of the universe, there are these fundamental laws at play governing how matter behaves.
At the tiniest levels.
Exactly.
And yet we still don't fully get the why behind it.
Right.
It's like we found this amazing secret, but we're still missing the key to unlock its deepest mysteries.
Yeah, that's a great way to put it.
So what are some of the current theories or ideas that physicists are exploring to try and answer these questions?
Well, one really interesting area of research is focused on connecting the Pauli Exclusion Principle to even more fundamental concept, like the nature of space-time itself.
Whoa, okay.
Some physicists believe there might be a deep connection there.
Between the principle and the fabric of the universe.
Exactly.
That sounds super complex.
It is.
But also fascinating.
It is a very active area of research.
Are there any other areas of research that are shedding light on this principle?
Another exciting avenue is exploring how matter behaves under extreme conditions.
Okay.
So really high temperatures, intense pressure, crazy density.
Okay.
Scientists are basically pushing the limits to see how the Pauli Exclusion Principle holds up in these extraordinary environments.
That's cool.
Yeah, it's pretty wild.
So by probing the extremes of the universe,
Yeah.
we might gain insights into one of its most fundamental laws.
Exactly.
That's kind of poetic in a way.
It is. It speaks to the interconnectedness of science.
Right.
From the smallest particles to the largest cosmic structures.
Yeah.
The laws of physics are all woven together.
It's like a giant tapestry.
Exactly.
And the Pauli Exclusion Principle is like one of the threads.
It's a crucial thread, though.
Right.
It helps us understand the patterns and relationships
that govern the universe.
Exactly.
This deep dive has been incredible.
I'm glad you enjoyed it.
We've explored the history, the science, the mysteries.
It's a rich topic, for sure.
It is.
Yeah.
But before we wrap up,
Yeah.
what final thoughts would you leave our listeners with?
I think the most important takeaway is the power of a simple idea.
Okay.
The Pauli Exclusion Principle is, at its heart, a simple statement.
Right.
About how particles behave.
Yeah.
But from that simplicity comes this incredible array of consequences.
That's amazing.
It shapes the structure of matter.
Right.
The behavior of stars. And even the potential for future technologies.
It's really remarkable.
It is a testament to the elegance and profundity of the laws that govern our universe.
Absolutely. To all our listeners out there.
Yeah.
I hope this deep dive has sparked your curiosity and left you with a sense of wonder about the world around us.
It's an amazing world out there.
It is never stop exploring.
Keep asking questions.
Never stop questioning.
You never know what you might discover.
Exactly. And who knows, maybe you'll be the one to unlock the next great scientific mystery.
It could happen.
That's awesome. Thanks for joining me on this deep dive.
It was my pleasure.